What's going on, you guys? Mr. Allen here, and we are about to solve for x in each one of these awesome examples. We got some exponentials, and we got some logs. They go together like peas and carrots, as Forrest Gump once said, or maybe spaghetti and meatball, if you're a Big Daddy fan, right? Remember that guy, the delivery guy? He's like, lamb and tuna fish, maybe spaghetti and meatball. Okay, let's do some math, okay? Enough with the references that you probably don't get. So we have 4 raised to the 2x minus 3. Equals 8 to the x. I'm starting off big league, dog, okay? So what in the heck do I do? Well, here's what's fun. You could use logs and bust out that calculator and go crazy with decimals, but 4 and 8 can both be written as 2 to a power. I can rewrite 4 as 2 squared to the 2x minus 3 equals 2 cubed to the x. And now I have power to a power, so I'm going to have 2, and then this 2, we can think of it as like that way. I think is a little bit easier, right? It's going to be to the 4x minus 6 equals 2 to the 3x. I have the same base, yes? That means that my exponents have to be equal. That is the one-to-one property of exponents. I'm going to drop them bases, drop it like it's hot, Snoop Dogg in the house, and now I have just my exponents equal to each other. I'm going to subtract 3x, I'm going to add 6. So if I subtract 3x minus 3x, add 6. Jenny's excited about this. I don't know if you hear her shaking out there, right? So now I have 4x minus 3x is x equals positive 6. That's a lot of different algebra going on there. But I got my answer, 6, whoop, whoop, right? I'd have 8 to the 6th power, whatever that is, and then I'd have 4 to the, let's see here, 12 minus 3. I need a calculator for that. I'm not going to do that. That's, I guess, to the 9th, whatever. Okay, anyways, moving on. Okay, if you plugged it in, it would work. I'm not going to do that right now. Next one. Oh, boy. We got fractions, bro. I'm terrified of fractions. Oh, wait. No, I'm not. I love me some fractions. Face your fears, dogs. All right. Once again, we can rewrite this guy as 3 to a power. 3 to what power gives me 81? 3 to the 4th power gives me 81. I wanted you to think about that, okay? I knew it. All right. So 3 to the 4th power gives me 81. 3 to the negative 4th would give me 1 over 81, right? Negative exponents give us reciprocals. So I'm going to have 3 to the x squared plus 5x equals 3 to the negative 4th. There we get, whoop, boom. I don't know why I was thinking about that. Okay, now I have like bases. I can set my exponents equal. Drop it like it's hot, baby. All right, we got x squared plus 5x equals negative 4. Now, if your brain is melting right now, you're like, bro, what do I do here? Huh? It's a quadratic, bro. Calm down. We've seen a million of these. We love factoring. It's my favorite F word. Next is fraction. Third is function, okay? I'm going to add 4 over because that's going to have it set equal to 0. Boom, equals 0. Now, what multiplies to 4 adds to 5. That's going to be 4 and 1 plus 4, x plus 1 equals 0. I'm going to set those both equal to 0. I'm running low on space, so I'm just going to write my answers. It's going to be negative 4, x equals negative 1. They are both going to work in this situation. If I plug in negative 4, I get 16 minus 20 is negative 4. 3 to the negative 4th, as we know, is 81. If I plug negative 1 in, I'm going to have 1 minus 5 is negative 4. Boom, diggity. With exponentials, we really don't have to worry about extraneous solutions because we have no domain restrictions with exponential functions. We can plug in anything we want for x, and it's going to work, okay? It's cool. Logs are a different beast as we step into log land here, beneath here. All right, so we had exponential amounts of fun here. Hopefully we can log some math fun over here. Jokes. All right. Here, oh boy, what do we do? Well, I believe I could condense this into one logarithm, yes? Okay, let's do that. So I'm going to have log of x times x plus 21. So that would just be what? X squared plus 21x, right? I'm going to multiply my two arguments, x times x plus 21, x times x plus 21, distribute that x, okay? That's what we got going on here, equals 2. Now, this is just a log. What's its base? Does it even have a base? Yes, it does. It's 10, all right? And now I'm going to pull a little loop and swoop out my back pocket to solve this thing, right? Loop it and swoop it. I get 10 squared equals x squared plus 21x. 10 squared, that's 100, dogs. 100 equals x squared plus 21x. Oh my goodness, another quadratic. If you're like, bro, I'm so glad we're done with the factoring unit. Oh no, it's here to stay, bro. All right, so I got 0 equals x squared plus 21x minus 100. So what multiplies to negative 100 and adds to 21? That's going to be 25 and negative 4. All right, I'm going to pop over here. I don't want to run a room. So we got x. So, all right. X plus 25, x minus 4, that equals 0. So I'll get x equals negative 25 and x equals positive 4. Now, I do need to check and see if these work, because with logs, we have the potential for extraneous solutions. If I plug it into the original red one right here, negative 25 would cause a negative here as well as a negative here. I cannot have a negative argument, therefore that is an extraneous solution. So a good test question, sometimes they'll say, which of the following is an extraneous solution? Negative 25 is an extraneous solution for this one because it went through the whole process. We got that as an answer, but it does not work in the original. The 4, however, plug 4 in, it's cool. Plug 4 in, that's cool. All right, boom, there we go. If you were to plug this in with your calculator, you would log of 4 plus log of 25 would equal 2. Kind of neat, kind of neat. Seems like magic, I feel like, you know? All right, last one here. We got subtraction now. I am going to condense this down to one logarithm. So we got log of x over 4, right? X divided by 4. Subtraction condenses down to division, whereas addition condenses to multiplication, as we saw over here, which gave us that. All right, equals log of 2. Now, I'm going to use what's called the one-to-one property of logarithms. Much like we did up here with exponents, it works for logs too. I have a log equals a log, and to the same base, I can drop them logs, set the arguments equal, just like we set the exponents equal. So I have x over 4 equals positive 2. Just multiply by 4, a little algebra 1 action coming at you, and I get 8. Now let's check and see if I plug 8 in. It is a positive logs argument. The argument is positive, so that's a good sign, right? That's really all you're going to check, especially if this is non-calculator. You're not going to plug it in, right? Because you don't have a calculator if it's a non-calc. So x equals 8 is Gucci. Dang, man. We went ham there, right? We logged some serious math hours there, and we had exponential amounts of fun. All right, I'll stop with the jokes. Have a great day, dogs.